From Nest 2021 shift 2 question 2. Let p h comma k with h positive k positive be a point on the ellipse x squared by a squared plus y squared by b squared equal to 1, where a is greater than b and both are positive, whose foci are f1 and f2. The normal at p intersects the major axis at q. If pf1 is to pf2 is 2 is to 1, then qf1 is to qf2 equals 3 is to 2, 2 is to 1, 1 is to 2, 1 is to 1. Let's draw the figure first. It is going to be a horizontal ellipse because a is greater than b, so it's a horizontal ellipse. Take it. Now what we can do is, let us first draw the normal. Let's first show the point P. First show the point P somewhere here. H comma k. This will be the tangent this will be the normal. Okay, so this is Q. If PF1 is to PF2, okay, foci. Say F1, say F2. Okay, so PF1 is to PF2 is given. P to F1 and P to F2 is 2 is to 1. Take it. Then what would be, according to them, QF1 upon QF2. Alright. Now, if you know the property of ellipse, then you will get the problem quickly. So the property goes something like this. If we fix a point source of light at f1, okay, if we fix a point source of light at f1, it is going to emit light in all directions. And suppose the surface of the ellipse, okay, if the surface of the ellipse, or let's say the interior of the ellipse, if it is a mirror, then all the rays that emerge out of f1, they will converge at f2. Okay, that's the property that which you can prove. And because of the laws of reflection, f1 pq will be equal to f2 pq. Okay, that's the reflecting property. We call it reflecting property of ellipse. We call it a reflecting property. That means if we have, okay, alternately if we have a point source at f2, if all the rays that you draw at f2, they get reflected along the ellipse, you will find that all of them will again converge to the second focus of the ellipse, that is f1. Okay, which automatically makes pq the angle bisector of f1 pq. Therefore pq is the bisector of angle f1 pf2. So we can now use the angle bisector property in triangle f1 pf2. What is the angle bisector property? f1p by f2p is equal to f1q by f2q. And because f1p by f2p is 2 is to 1, the other ratio will also be same, and that is 2 is to 1. So options. Okay, that is option C. Well, now suppose you did not know that property. The derivation is very lengthy, okay, and I don't think that is recommended also to derive, but we can definitely eliminate options B and D even if our figure is not very much to the scale, we can say that PQ or Q will be closer to F2 than F1. That's qualitative argument that we are making, qualitative arguments. Okay, Q will be closer to F2 than F1, at least in this case, right? So do you agree that QF1 will be greater than QF2? So we can eliminate B and D for sure. We can eliminate B and D for sure. So it then is either A or C, but still again that is not resolved, that issue is not yet resolved unless you know the reflecting property of ellipse. But if you go with the derivation, that is that is going to take some time. We have to first find the equation of tangent, an equation of normal, then you have to let it intersect the x-axis at Q, and then you have to find the ratio of F1Q to F2Q. You can try that if you want. HW is prove the reflecting property of ellipse. Did everybody understand what exactly are you supposed to prove? You are supposed to prove that the normal, when it intersects the major axis of the ellipse, okay, that normal is actually the angle bisector, of the angle which that particular point subtends, which that particular point forms with the foci. So F1P F2's angle bisector is the normal and also the tangent. Will you be able to prove this? Give it a try, else I will send you the solution. Okay, now this is the figure that I wanted you to take a note of. The 2 points that you see here are the foci. The 2 points here that you see are the foci. And you can see that all the rays that are emerging out of one of the foci, they are basically converging at the other point. They are basically converging at the other point. Have you understood this? That's what I meant by the reflecting property of ellipse.